What's going on, everybody? I'm here to show all of you guys, as you can see down here, how to make circles in Minecraft. This is a multi-part video for circles, domes, and arches, and as you can see we have many different circles here of varying sizes. I'm going to explain a bit about how to make these and the math behind them so you guys can make them yourselves and you can know how we got here. Because it seems to me like everybody has videos on YouTube of how to make circles, domes, arches, and they say, hey look, copy and paste this. Pretty much just pause the video, watch what I'm doing, and replicate it, but that's not going to teach you anything. You're not going to get any more knowledge from that. And then the other half of the videos are, hey, look at this PC app. Go on your computer and play your PlayStation while you're also using your computer, which I think is just ludicrous. I want to sit down on my PlayStation, play video games like I'm supposed to. That's what it's meant to be. So what I'm going to do here is go through, there's a lot of math involved, but once you're done with it, I'm going to go ahead and, you're going to be a lot better off, and I'm going to simplify a lot of it and go ahead and give you the steps you need to do to make circles like this yourself and to make them consistently and not have to have a third-party app or, not to help you with it or not even have to carry it. So with that, let's go ahead and get started on some of this science part. Okay. The first thing I want to do is address some basic concepts and constants that we'll be using throughout the video. The circle equation for a circle whose origin is 0, 0 is x squared plus y squared equals radius squared. This means that when you plug the numbers into it, they will always be equal for a circle whose origin is 0, 0. The next point on the list is that we will always be drawing our circles from the second octant. Excuse me. That is starting from the very top and working southeast until we hit the first octant. This is all the information we need because from this we can copy and paste it into every other part of the circle because it has what's called eightfold symmetry. That being said, now we move on to our first problem. We are trying to draw a circle on a grid, so you can only go east or southeast. It's not in a perfect arch. You can express the circle formula as a function, meaning that you can actually plug numbers in to get an answer. And this is written: the function of xy equals x squared plus y squared minus radius squared equals 0. Meaning that when you plug all these numbers in, it'll equal 0 for a perfect circle. Now normally, the function's perfect, but in our case, our results are not going to be 0 every time. Knowing this, we can plug it in, and when our numbers come out, we'll see what we're going to get in regards to 0. You could calculate the equation at each given point to find out where the east and southeast block sits in regards to the perfect formula, meaning that you compare each one and see where they stand as far as 0. However, we can actually skip this and make it a little bit easier using the midpoint equation. The midpoint of our east and southeast blocks is our theoretical perfect point on our grid, meaning that if it was a perfect circle, if we could squeeze it down smaller, it would go right in between those. So we only need to compare the midpoint to the perfect equation. And then after that, we can see the midpoint of those, and we can do that in regards to 0. The midpoint is always going to be equal to 1 block east and a half a block southeast. Or half a block south. It's going to end up southeast. And we can represent this in our equation as xp, which means the previous x, and yp, the previous y. So xp plus 1, yp minus 1/2, meaning that's going over 1 and downright 1/2. This will be the quadrant that we always use whenever we plug it into our equation. Now, once we're done with this, we can represent the outcome of this equation as any square to be q. As it's written here, when you use the real numbers, you always get a specific number, like -3 or 5. But we'll get there soon. This number is our reference point to the real equation, which should yield 0. So that's what we're going to use to find out if we're on the circle, close to it, over it, and we're going to use that at each point to find out where we're at. Meaning that as we get close to 0 without going over, we're trying to reach that perfect point. If we go over, it means that we're outside the circle and making a brand new shape. But if we're inside the circle, or if we're under 0, we are safely inside the circle. Now, to avoid doing this equation every single time for the east and southeast point, every time we plot a point, we need to find the next point we can use the next midpoint we can use to find the change in Q. And there's a formula to go by for each step. Because the change in Q is always going to be the same distance if you move east or southeast. And then the reason it's going to be the same is because every block is equal in regards to that. So as you can see, there's going to be this line or this line is the midpoint, the next midpoint, and they're the same distance away every time. So what we do that is we can simplify the math because we know the change is going to be the same every single time. So for every time you go southeast, the change will always be 2xp minus yp plus 5. Meaning that instead of finding the new Q every single time, we can just add the old Q to the change, and then we'll find out the new Q. And the same thing goes for the east point. The change in formula will be 2x previous plus 3. So simply put, you're adding the change to the previous Q to find out the new Q. And then you're doing all this while doing the midpoint equation for every single one. Okay, so now we know how to find the next point in our circle at every given point by adding our change into what we had in our Q. But we are not ready to make circles. We never found the starting Q that will be set up at the very beginning. So we can find that out now. Because you can only add the change in Q to the Q you have, and you don't have a starting Q. More importantly, when you don't have a starting Q, you're not sure if you're going east or southeast. So we need to find the starting Q. Because we'll always be starting at the second octant, we can simplify this whole thing into a nice equation using constants. We know x is always 0 and y is always equal to radius. So plugging that into our equation for a circle, we simply get 5/4 minus r. Now this is enough to actually satisfy for our starting Q, but this is going to give you fractions every answer, and it's going to end up giving you that your equation is going to come out to if Q is less than 1/2, not if Q is less than 0. So in order to simplify this without changing any of the math, or without damaging the equation, rather, you can simplify this by getting rid of the 1/2 and starting it as a new point. So you're going to do minus 1/2, which would equal Q start will be equal to 1 minus r. And we can express Q start as a new expression called h. Meaning, now we have everything we need to start plotting points, and now we have h, x, y, and radius. I know it seems like a lot, and I kind of went through it very fast, and what I'm going to do now is give you an example and try and go through it a little bit slower so we can all get on the same page, because that was just a lot of background information to let you know how we got here. Okay. So now that we have our starting numbers, I'm going to give you an example and we're going to go through this. Our starting radius is going to be 8. Starting y is 8 because it's the same. X is going to be 0 and h is going to be negative 7. And now, because of this, we're going to start mapping how you would any given circle. Meaning that if this circle was 15, 20, 700, no matter how big the circle was, you start with the same equation and work your way down in steps. And I find that the best way to do this as well is to keep it in a grid. Because when everything's on a grid, your previous numbers are always going to be there, easily accessible, so you don't have to dig for them. This origin block is going to be the green block. That's our starting block. If you were looking in Minecraft while you're building, that's the block you start at, and you do not count that into your equation. So if you notice here, it goes up 1, 2, 3, 4, 5, 6, 7, 8. It goes up 8 from the origin block, and then also goes out in the opposite direction. So, that being said, you'll plug your numbers into your formula. Starting h is negative 7, meaning that we're going to go east. So we go east. From the east point, we now have to find where we're going next. And we know how to do that because we've already plugged in all of our numbers before, and we're going to use the same equation. So we are now at point 1, 8. The formula, because we went east, to find the change is now going to be negative 7, our previous h, plus 2 times 0, our previous x, plus 3. Always remember to use your previous numbers, because if not, you're going to end up with something wrong. Your math is going to be wrong, and your circle might be askew. So therefore, the answer comes out to be negative 4. Negative 4 is still under 0, meaning that we'll go east again. After we went east again, we're now at point 28. Now that we're at 0.28, we're going to plug in the same formula in the top right shown. We're going to do -4, our previous h, plus 2 times 1, because 1 was our previous x, plus 3. The answer comes out to 1. Now this is positive, meaning that if you place this point east, you would now be outside the circle. Our theoretical perfect circle, if you place this point, this block east, you'd be outside it. So you have to go southeast to maintain as close as you can to a perfect circle. Now here's where things change. Because we went southeast, we are now at 0.37, and from 0.37 we have to use a different formula. This next one's going to be 1, our previous h, plus 2 times x minus y, plus 5. The first thing you're going to do is x minus y. Then you're going to multiply that by 2. After you multiply it by 2, then you add your other sides. So the answer is going to come out to be -6, and then back on track again, -6 is going to plot the east point because it's under 0. You plot the east point, and then from there you rinse and repeat. And you're going to do this down every single step. Next one's going to be 4, 7. -6, our previous h, plus 2 times 3, our previous x, plus 3. The answer is 3. Now we're going to plot the southeast block. And then do this the last time. We're going to get 2, and we're going to plot the southeast block. Now from here, x is now greater than y, meaning that you are now in the first octant. Because at any point in time, if x is greater than y, if you could imagine your circle being your first and second octants being cut in half, you're now in the first octant. So you stop there. At any point in time, if it was 5, 5, you would stop. 6, 5, you stop. 7, 5, well, it won't be that because you don't give it a chance to skip 2 points, but you get the idea. Now that we have this, what we're going to do is use that eightfold symmetry and go back and pretty much redraw this on every other corner from our main x, I guess you can call it. It's more of a plus sign, but you know, x on the side. So, because whenever you start, you're going to draw your radius on up, down, left, and right on all 4. You're going to draw your radius. So from here, if you went over 1, 2, 3, 4, 5, 6, 7, 8, to where your theoretical axis would be on this one, you would go the same equation on the side. You would go up, up, up to the left, and then up again, and then up to the left, up to the left. And that's the bottom right, the first octant. I'm drawing the first octant using the same squares. Then you rinse and repeat for the entire circle. It is a lot to take in, but now what we're going to do is I'm going to go back and I'm going to show you a quick example of actually making this in Minecraft, and then we'll go from there. This is going to be the first part, and we're going to make arches next, and we're going to show you how this same concept applies into every single building that involves arches, circles, and domes. Alright, so what we're going to do is we're going to start with our main block, like I was talking about earlier, our origin block. Bam. Now we're going to make our radius. 1, 2, 3, 4, 5, 6, 7, 8. Now from here, I want you to go on all 4 sides. 1, 2, 3, 4, 5, 6, 7, 8. Same thing over here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now here's where our equation comes into play, because we're going to go up here, and after we've already done all our math, so you have all your math there. We're going to go, our first point's going to be east, second point, east as well, next point is southeast, next point's going to be east, and then we're going to have 2 points southeast after that, southeast, southeast. And from there, this is our first, if you look at here, boop, imagine this cut right here. That is our second octant right here. Now we're going to draw the first one. Well, I guess you can call it drawing. Boop, and now it's going to overlap. Because normally, like I showed you, I would have to go here, here, to finish our east, east, southeast, east, southeast, southeast. However, because we've already done it on this side, these 2 points overlap. And that's because it went into 6, 5. Had our last point equaled 5, 5, we would only have one block that overlaps, because that one block would be the medium point, the perfect middle for our first, second octants. Now, because of that, we can go do it on this side and repeat on there. East, east, southeast, east, southeast, southeast. And now we'll do it here. East, east, southeast, east, bam, southeast, southeast, already done. Now we'll do it here. 1, 2, southeast, east, southeast, southeast. Boom, 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 boom. Nope, one last side over here. 1, 2, southeast, east, I believe. Yep, southeast, southeast, east, east. And I understand this is actually west. I'm saying east and southeast because I just want to remember it in my head. You can know east, southeast, up, down, left, or right. Whatever helps you remember it the best. And now if we back up, boom, we've got our circle. And the same thing applies even for this really big one. What I did is I went through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this one's 15 radius, which means it'd be a total of 31 across, because it's 15, 15. You don't actually count that point, so it's 15 on all sides, ignoring that point. And then from here, we would have went negative 14 as our h, and we would have found our starting h, and we would have went boop a doop a doop, and we would have actually found our formula all the way over to, I want to say, that point. Right in there should be about where the first and second octant are cut in half. And yeah, this formula is solid, guys. Like, this formula will work every time, no matter how big the circle, no matter what you're working on. This is how you do it. So no longer do you have to worry about copying, pasting someone's stuff, or going online to find a program to do all this stuff for you. It's simple math. You just plug in your numbers and then rinse and repeat. It can be time consuming to go through it from 15 to 14 to 13 to 12, to do all of these to find the circle. But, it's not too bad, because once you get it, you've got it. Because at any point in time, once I figured this out, like this motion, for example, I know that every time it's going to be east, 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 southeast, east, east, southeast, east, southeast, southeast. And I know every single time for 15, I can actually get like a book or, a journal, and I can write that down. So now every time I do a circle of 15, I have a reference, and in that reference, it shows me east, southeast, blah, 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 for any given point that I decided to record, And, next couple of videos, what we're going to do is go in from this circle, teach you how to make an arch, because if you see here, if you cut that bottom half out of the circle, whoop, it's an arch. And you can actually think of that in 3 dimensions as if you were walking down into the sand. And then from there, we can actually go into domes. And from domes, we can go into full spheres. But, this has been the video. I hope you guys enjoyed it. And the biggest thing is I hope you learned something. It's a lot of math, and it seems kind of complicated at first. But once you're done, man, you have infinite possibilities. You don't have to wait to have somebody else tell you what to do, to get a program to tell you to do it for you. You know what I'm saying? You've got all the tools you need to make any size circle anywhere in the game. And that's just, I think that's something good in my opinion. But, thank you guys very much for watching. I'm so glad that whoever stayed this long gave the video a chance. And if you feel like it helped you, tell your friends, tell anybody you think that can really benefit from this, because that's all I want, is people building cooler, better, bigger things. But thank you very much, and you guys have a nice evening.